Hello! Welcome to today's lesson on constructing ray diagrams for virtual images produced by a convex lens. Today we will learn to construct ray diagrams for virtual images from convex lenses. So far, you are familiar with the features of lenses, including the differences between convex and concave lenses. Additionally, you know the distinction between real and virtual images, and we've discussed ray diagrams for real images from convex lenses as well as magnification. This allows us to now delve deeper into how virtual images are formed by convex lenses in terms of ray diagrams. Let's get started. Let's dive into the process of constructing a ray diagram for a virtual image produced by a convex lens. This will help you visualize how light behaves and understand the principles of optics. Start by drawing a horizontal line across your paper. This line represents the principal axis of the lens, a baseline from which we will measure all distances. Next, place the convex lens at the center of the principal axis. Illustrate this with a simple symbol, usually a shape with arrows pointing outward to show that it is a convex lens. Then, identify and mark the focal points F on either side of the lens. The focal points should be equidistant from the center of the lens. These points are crucial for tracing the path of light rays as they reflect through the lens. We then represent the object by drawing an arrow above the principal axis, situated between the focal point F and the lens on the left side. The tip of the arrow, which is the top of the object, is where we will trace our light rays from. From the tip of the object, draw a ray that runs parallel to the principal axis towards the lens. When this ray hits the lens, it will refract and pass through the focal point on the right side of the lens. Draw this refracted ray accordingly. Next, draw another ray from the tip of the object straight through the center of the lens. This ray does not bend but continues in a straight line. To find the virtual image, we need to extend the refracted rays backward. Use dashed lines to denote these extensions. The dashed lines should trace back towards the side of the object. Our objective is to determine the point at which these extended rays appear to converge. Then identify the intersection of the extended rays on the same side as the object indicates the location of the virtual image. Draw the image at this intersection point. It will be an arrow pointing upwards, showing that the image is upright. The virtual image produced by the convex lens is upright and magnified compared to the original object. This means the image will appear larger and in the same orientation as the object, but positioned on the same side of the lens. By constructing ray diagrams in this manner, you can visually and accurately determine the properties of images formed by convex lenses. In today's lesson, we focused on constructing ray diagrams to understand how virtual images are produced by convex lenses. We began by setting up the diagram, which included drawing the principal axis, the convex lens, and marking the focal points. Next, we placed the object between the focal point and the lens and drew two key rays. One parallel to the principal axis that refracts through the focal point and another passing directly through the center of the lens. By extending these rays backward as dashed lines, we identified where they appear to intersect, indicating the position of the virtual image. We concluded that the virtual image formed is upright and magnified compared to the object. This visual exercise reinforced our understanding of how light behaves when passing through convex lenses and helped us grasp the principles of virtual image formation. Watch the rest of the GCSE physics course at Sophos Education